Alright, we're finding the area between two different curves. Alright, when you're trying to find the area between two curves, like so, here we have two different functions that intersect, and we're trying to find the space that's in between these graphs, which would be marker work right here, and your equation will be this right here. The integral of your boundaries here and here of your top function minus your bottom function, and we're going to call our top function f of x and our bottom one g of x. So we'll have f of x here, g of x here. Now that's with a top and a bottom graph. That's distinctly a top minus bottom because you have one of your functions on the top, your other one's on the bottom. Now, another example here is your right minus left. Right here we have a function straight up and down that's definitely on the right compared to this one. And we're trying to find this space here. So we'll call this integral will be the integral of your boundaries on your y-axis from here to here of your right function. We'll call this f of x, minus your left function. We'll call that g of x. So that's how you set up an area problem for finding the area between two different curves. Let's do an example here. Find the area between the graphs y equals 6 minus x squared and x equals 2. First of all, what you need to do is graph your two functions. Right here, right here. I already have them graphed. We got an upside down parabola and a horizontal line. Now, we need to understand what we're trying to find the area of, which I told you up here, is the space in between these two graphs. I'm going to color it in. It's a black marker. That's what we're trying to find right there. The area between those two different functions. Now we know that our equation right here, area of your integral with your boundaries, our boundaries here are going to be -2 on our x-axis, -2 to +2 right there. Let's go ahead and set up our integral from -2 to +2. We got that there. I've already got it done. We just kind of talk our way through it. From -2 to +2 of your top graph, we'll call it f of x. We've already spoken that up here. F of x minus our bottom function, g of x. So we get here and we see we need to simplify this right here. We come down and reduce it to 4 minus x squared dx. Once we get there, we can start integrating. When we integrate this here, we get 4x minus x cubed over 3 from -2 to +2. When you get here, all you have to do is substitution and simplify. It's quite simple, but if you don't pay attention, you'll overlook a step. We start out with the top number, +2. All you do is substitute in the 2 for each x you see. 4x, we plug in 4 times 2 minus 2 cubed over 3. When you get that one, we want to put those in parentheses and subtract from the -2. So you do the same thing with the -2. Just substitute in for each x. 4 times -2 minus -2 cubed over 3. We simplify this first equation. We get 8 minus 8 over 3. The next one we subtract. Don't forget your sign. Subtract the next equation. It will be -8 plus 8 over 3. Simplify that down. We just take the parentheses away. Simplify that. We add our whole numbers. 16 minus 16 over 3. That's simple. All you do now from there on is just simplify. you get 13 over 3, and that can be your final answer. Or if you would like to go on down to a decimal, you approximate, and that would be 10.67. And that, in a quick way, is how you find the area between two separate curves, or separate functions.